Hi everyone! Welcome to the topic of rationalizing the numerator or denominator. Let's take a look at this problem. When you first see this limit, your first thing that you should do, without a doubt, is try to plug in the x value. So we're going to try to take this 3 and plug in. We've got no issues in the numerator. We get a 0, and that's not a big deal. But unfortunately, in the denominator, we get a root 3 minus root 3, which is a 0, and we cannot have a 0 in the denominator. So this is a sign right here that we need to use a different method. And I'm going to tell you that this method is called the rationalizing the numerator or the denominator. Rationalizing is a fun way of basically saying, let's get rid of the square roots. And in this case, our square roots are in the denominator, so we'd actually be rationalizing the denominator. To get rid of our square roots, we're going to multiply by the conjugate. This is a word that you heard in pre-calc. And essentially, the conjugate is exactly the same thing as what you're trying to get rid of. But instead of having a minus sign, you would put a plus sign. All right. If I'm going to multiply by square root of x plus root 3 in the denominator, I better multiply by that same thing in the numerator. And the reason why is because we can't just multiply by something. We have to multiply by 1 so that we're not changing the expression. Now here's a really important point that I'm about to make. This is everyone's biggest mistake. If I'm not trying to get rid of anything bad in the numerator per se, I don't want you to multiply through. In other words, what I'm trying to say here is you just want to leave that as x squared minus 9 times the square root of x plus root 3. Just leave it like that. Very rarely are you going to have to multiply through in the numerator and the denominator. However, in the denominator, when we multiply these two things, we're going to see that something cancels. So we do want to do FOIL, first, outer, inner, last. I'm going to remind you of the box method if you prefer this better. I think it's slower, but maybe for our first problem we'll do it. So we're going to multiply root x minus root 3 times the square root of x plus root 3. All right, let's fill in our box here. Root x times root x is going to be square root of x squared, and that cancels, and we're just left with x. Square root of x times negative root 3 is a negative root 3x. Root 3 times root x is a positive root 3x. And we've got a root 3 times a negative root 3. Well, that gives me negative the square root of 9. Well, what's the square root of 9? It's just 3. So this just gives me negative 3. And look at this. What happens to a negative root 3x and a positive root 3x? They cancel. So what we're left with in my denominator is simply an x minus 3. At this point, you say, can I plug in the 3? Well, you can't. That's still going to give us a 0 in the denominator. So at this point, you have to look for something in the numerator that's going to cancel out. Well, I don't see anything, but what I do see is that I can factor x squared minus 9. So the limit as x approaches 3, I can take x squared minus 9, and I know that's an x minus 3, and that's an x plus 3. You could try foiling that out or doing the box method, and you would see, in this case, you get an x squared minus 3x plus 3x minus 9. These two things cancel, and x squared minus 9 is the same thing as x minus 3 times x plus 3. And don't forget, I still need to write this expression, which is the square root of x plus root 3. And that's all going to be over x minus 3. Next thing that happens here is that our x minus 3's cancel. And now I'm left with the limit as x approaches 3 of x plus 3 times the square root of x plus root 3 all over 1. Now can I plug in? Yes, I can. So I'm going to take that 3 and I'm going to plug in. That's going to give me 3 plus 3 times the square root of 3 plus square root of 3 all over 1. Well, what does that give us? That gives us 3 plus 3 is 6. Root 3 plus root 3 is going to be a 2 root 3. And who cares about the divide by 1, right? So this is going to end up giving us a 12 root 3. There we are. Shall we try another one? If you want, you can go ahead and pause this video and see if you get the same answer as me. All right, let's tackle this problem. Again, first thing you should do is plug in your x value, see if that works. Unfortunately, the square root of 25 gives me just a plain old 5, and that's 5 minus 5, which is 0 in the denominator. So that's not good. We're going to have to do something, and that thing is rationalizing the denominator. So what am I going to multiply by? That's going to be a square root of x plus 5 and a square root of x plus 5. These two things have to match because I need to multiply by 1. I don't want to change anything. All right, multiplying across. Remember I told you the number one mistake here is multiplying through when you shouldn't. So in the numerator, there's nothing bad, so I'm just going to keep it as x minus 25 times the square root of x plus 5. So I've not done anything but just rewrite those two expressions. But instead of doing box method this time, which you're welcome to do, let's just do FOIL. So first times first, root x times root x is just x. Outer, my F, this is my O. Outer is root x times 5 is going to be a 5 root x. My inners are going to be a negative 5 root x. And my last is going to be a negative 5 times a 5, which is a minus 25. If you have properly multiplied by the conjugate, then your two inner terms will always cancel. In other words, your O and your I will always cancel each other out, so you just really need to do your first and your last. So you can see here that a 5 root x and a negative 5 root x cancel. So what do I really have? I have the limit as x approaches 25, and the numerator I've got x minus 25, root x plus 5, and on the denominator I simply have x minus 25. And you're correct if you say, oh, these two things cancel, and I'm left with the limit as x approaches 25 of the square root of x plus 5. So plugging into that, I can now drop my limit because I'm plugging in now. I get square root of 25 plus 5, which is equal to 5 plus 5, which is equal to 10. Awesome. All right, this is the last one we're going to do to practice rationalizing the numerator or the denominator. And a quick look at this, you should ask yourself, am I going to be rationalizing the numerator or the denominator? Well, in this case, you're going to rationalize the numerator, that's that top part of the fraction, because we've got that square root in the numerator. However, we really should try plugging in 7. Does it work? No go. We've got to do something a little bit more challenging. So we've got to rationalize this as opposed to just plain old plugging in. All right, so I'm going to multiply by the square root of x plus 2, and then it's going to be plus 3. Same thing in the denominator. They have to match because you need to multiply by 1. In the denominator here, I don't want to change anything, so I'm just going to rewrite it. I guess I put that in the wrong order. I'm going to do my x minus 7 first, although it doesn't matter. And then we've got our square root of x plus 2 plus 3. In the numerator, we will have, and since I've already brought this up, because they're conjugates, we don't have to do the outer or the inner. We just have to do the first and the last. So what is the first times the first? Well, that's just going to be an x plus 2. And then what's the last times the last? Well, that's just going to be a minus 9. Well, look at this. This is interesting. What does x plus 2 minus 9 become? Well, that simplifies to x minus 7, because 2 minus 9 is negative 7. So you should get excited now. This always happens in one of these problems. If it doesn't, you should find your mistake. You should say to yourself, oh, the x minus 7's cancel. So now I'm left with the limit as x approaches 7 of 1 over the square root of x plus 2 plus 3. Okay, so plugging into that, I'm going to get, let me get a different color here. That's going to be equal to 1 over the square root of 9 plus 3, right? Because I took the 7 and I plugged that in right there. So that's going to be equal to 1 over 3 plus 3 is equal to 1/6. All right, that's it, folks, for rationalizing the numerator or the denominator. These problems are fairly obvious. It's almost always when you see a square root that tells you that, hey, I think that this is the method to go about. Thanks for watching. Have a beautiful day.